All chemical reactions have a specific empirical ratio. This ratio represents the smallest amount of reactants needed to produce a product. Not all chemical reactions follow the empirical formula. When this happens, there is a reactant that will be completely used up called a limiting reactant. With this information, we conducted a lab to identify the limiting reactant in a chemical reaction and to observe how different ratios coincide with the limiting reactant. In our experiment, we filled one burette with potassium hydroxide and another with copper sulfate. We then used the burettes to fill 8 test tubes with 5 millimeters of copper sulfate and escalating amounts of potassium hydroxide. We then added water to the test tubes to make the solutions equal in height. Then we stirred the solutions to quicken the formation of the precipitate. The height of the precipitate in each.
We collected data from our experiment and noticed some interesting patterns. Our precipitates in the solutions had a drastic increase in height after the 4:5 ratio of potassium hydroxide to copper sulfate. We also noticed that after the 4:5 ratio, the height leveled out around 80 to 90 millimeters. With the data that was collected, we concluded that the differences in height were due to the limiting reactant exceeding the ratio that the empirical formula called for. Because the empirical formula for potassium hydroxide to copper sulfate was 2:1, the ratios of 1:1 and above reached the maximum height of the precipitate that could be formed. The change from potassium hydroxide being the limiting reactant to copper sulfate being the limiting reactant contributed to the significant change in height for the precipitates. In the higher ratios, there was an excessive amount of potassium hydroxide left over. In the lower ratios, there was not enough potassium hydroxide.
In conclusion, the higher amounts of precipitate was due to the potassium hydroxide reaching the amount that made full use of the amount of copper sulfate.